No, not from my side.
Okay, so everything is cool. We had so Neil, now you're comfortable with the business aspect of whatever we are doing. We had a healthy discussion last time, understanding how it can help
Mm,
in the daily business.
yeah, yeah, definitely.
Okay, so let me tell you one of the projects that I did and how you know it helped me in applying machine learning. So we applied. I submitted my project from Johnson Johnson to NASSCOM AI Game Changer Awards. So we made it to the final rounds, but we were not selected in the final publication. So they selected top 12 out of 200 entries for the final publication. We could not make into the final publication, but we were selected for the final round. So let me tell you how machine learning helped me in applying algorithms to actual business. So if you guys are aware of the FMCG business, okay, so Johnson Johnson Baby has three verticals, right? Health, medical, pharma, and consumer. Consumer is like the Johnson Baby and Aveeno, the Neutrogena. I think that is less common in the US. Johnson Johnson is more known for Janssen and the other components of the business in US, Tylenol and all. So, for in India, Listerine and Johnson's Baby is the most famous consumer products in India. So, uh, so what my project was basically, I had to find patterns in. So every consumer goods or anything which is dealing with a supply chain will have some inventory in it, right? So there will be a production, there will be some inventory, and then there will be sales. Okay, so your main objective of supply chain is to provide the right product at the right place to the right customer, okay, through the right means. So that is the objective of supply chain. So for example, if you want to see, so the very important component in a supply chain is your lead time. What is lead time? Is basically that the you cannot, like for example, if you say that I want this product today, I cannot provide you the product today because I have to make it, right? And there has to be some time that will be involved in making the product, so I have to be ready with that product. So how much time does it take me to produce that product? For example, that is called the lead time. Or how much time does it take me to take the product to you guys? That is the lead time. Okay. So for example, if you want a product today, I have to prepare it, say 2 months before. Okay. I have to start preparing. I have to take the raw materials. I have to take into production, and then I have to supply it to you, reach to the nearest store, and I mean, go to the nearest store near you so that you can easily have access to it. So there's a lead time involved in it, right? So you cannot always have your make to order. That's called make to order. You cannot have like today you want the product and tomorrow I deliver. Or sorry, yesterday you told me I want the product and today I deliver. Okay, so it cannot be like that. So every supply chain will have some inventory, right? So the inventory is there in the nearest store, in a store near you, so that whenever you come, we are ready with that product which was produced, let's say 2 3 months ago, and I have the inventory. So inventory tends to be a very important part of supply chain. But inventory, since you have inventory, it will be a cost associated, right? Because you are storing those products, you're uh, kind of you're taking up of space where you're storing the products. So there's particular inventory holding cost, right? So that is okay. That is still okay. But the problem is, what if you had forecasted that you will be needing this product? You had just forecasted, right? You didn't tell me that. No one tells Johnson Johnson that I want a Johnson baby powder next. I mean, 3 months down the line, get it ready for me. That doesn't work, right? It may happen in very low volume business like the airplanes. Okay, airplanes are not made on forecast basis. They are made to order. Or ships, right? No one builds ships every month. It's based on the requirement, but it cannot be the same in case of powders, right? You don't tell me, or you don't tell Johnson Johnson that I want a product 3 months down the line. So I forecasted that there will be 1,000 units that is going to sell 3 months down the line. So I produced 1,000 units. But what if I land up in just selling 200 units? It can be, right? I just forecasted, and it could be wrong. So the problem here is basically your inventory can go stale. Okay, so your inventory, the stale inventory is basically a product which expired inside my inventory, right? It was, I could not sell it, and it crossed its shelf life and expired. So that product I cannot obviously sell to customers. So my project was basically to find patterns in inventory. I mean, all the variables which leads to the inventory, and find patterns which lead to the most probable products that lead tend to expire. Now, when you are given a project, how do you proceed? Okay, so for example, I'll guide you how I started. Okay, so my project name was, you have to identify patterns using advanced machine learning techniques to reduce the expired part of your inventory. Okay, this is your problem statement. Now, first of all, as a data scientist, or whenever you're doing an advanced machine learning problems, algorithms come later, a lot later. Okay, first of all is to get your data, and any algorithm you apply, if your data is garbage, your output will be garbage. Take that to the bank. It's guaranteed that if you have a garbage data, apply advanced deep learning models, your output will be garbage. No model can save you. So the first and foremost thing is to get the proper data. Now, for example, right now what we have been doing is Boston data. It's always, it's ready, right? It's kind of, the data is structured, it's given in a table, you already have a output, you just need to train. But it's not the same case in a real business, right? It's more of, it doesn't happen like that. So the first problem is to, get the data. Now, after you get the data, how do you get the data? First of all, what variables do you need to? So there comes a business sense, right? So for example, inventory, what all things can be taken into consideration? How much I'm over forecasting or under forecasting? Okay, so if I'm over forecasting, let's say I'm putting more, producing more than what I'm trying to sell, it is a tendency to go into slog. If my lead time is, let's say, much more than my shelf life, I mean, my product shelf life is 6 months, and my lead time to reach the customer is 8 months, it means I'm always tending to, go into expiry. But that obviously doesn't happen. So you take a ratio. Okay, you include both variables, lead time and shelf life, and the model will understand what is the ratio between these two. That's where the interaction comes into part, right? What is the interaction between these two variables, such that the interaction between these two will lead to the probability of expiry. Okay, then you take into consideration which market you are selling, right? What is the production side? What is the, now Johnson Johnson is widespread in a lot of countries, right? So it's present in Asia, it's present in US, it's present in Brazil, it's present in Europe, it's present in Middle East, everywhere, all over the world, right? Now there are certain products which may be, produced in US and sold in Asia Pacific. Okay, or there may be products which are produced in Brazil, sold in Japan. Okay, so now you understand the lead times associated, right? A product which is being produced in US and sold in Japan will have at least 2 months of lead time from its production, then its logistics and all. So this lead time comes into a very big variable, right now. Okay, then you have the market, you have the franchise, which franchise you're selling. So Johnson Baby, is it a oil, is it a powder? So all these variables you get into what has been the past trends of this particular invoicing. I mean, what is the rate of invoicing? How frequently this product has been invoiced? How frequently it has been bought by customers? For example, if my last invoicing for this product was, let's say, 7 months ago, it means people are not buying this. I'm still forecasting and building on my inventory, but people are not buying it. So there comes, there's this problem associated. So now I have all these variables. Now I clean my data. I form good variables out of it. So that's called feature engineering. So for example, lead time by shelf life, I keep it as a variable. I don't keep it lead time and shelf life as a independent variables. You can also keep that, not a problem, because your algorithm will try to understand the interaction between these two variables. But it's always better if you know something you already have. I mean, if you have something or you already know that lead time is to shelf life ratio is important, then you directly feed that variable, right? Then you have all the variables, the forecasting accuracies and all. Now if I run the algorithm, first what we did is we find out which are the most important variables. So, for example, forecasting accuracy came up to be the very big determining factor. If you are over forecasting more than 20%, you are tending to be more expired. I mean, tending to that the inventory will expire more with a probability of greater than 0.7. Okay. If your forecasting accuracy is more than 40%, the probability of expiry is greater than zero point 0.9. So these are very important business insights, right? So so for example, how I got this. So like we discussed, first we had the important variables. Now, yeah, last time, like I said to Sunil, uh, for example, my model has prepared all the thing, the model has run. Now I feed in Johnson's baby oil. My forecasting accuracy is, let's say 80%. Okay, what if my forecasting accuracy dips to 60%? I input 60% here. I keep all the variables same. Okay, I keep the lead time same, or I keep the shelf life same, I keep the market same, and then see what is the effect on the probability. So I've just changed the what do you say, the forecasting accuracy, and I'm seeing what is the tendency of my product to go into expiry. And I see that if I changed my forecasting accuracy from 80% to 60%, I was actually telling the error for, earlier, 20% and 40%. So if I take into consideration the accuracy, so 80% and 60%. So if I change that, my expiry probability of expiry in the inventory will change, let's say, from zero point 0.7 to zero point 0.9. So this is a very important business insight. So when I tell this to my boss, he says, "Oh, that's great." No, I'm not sharing any code. I'm just telling you because I can't share the code. It's not allowed. I mean, I'm just telling you a case study that my company did. I cannot share the code here actually. But anyways, what I'm trying to give you the essence is how improve the business, or you have effects in the business using machine learning. It's not just of prediction. I just don't want expiry probabilities from you. I want how, if I change the forecasting, for example, if I change the lead time, if I increase my lead time, or if I decrease my lead time. So for example, if a product is from sourced from US and Japan, its lead time is 60 days, probability of expiry is 0.8. What if I can produce that in Brazil, or if I can produce that in Asia only, and I'll drop my lead time to 30 days, what will be the probability of expiry? And that came up to be 0.4. Now what you do is you take an expectation of so the expected difference is, like, let's say in earlier it was zero point 0.8, now it is 0.4. So you're taking on an average historically how much you have been expiring over a year. Now if you change this probability, what is the expected dip in the inventory, and then you see that if you save this much of cost, will it really make sense to produce the or shift the production capacity from US to Asia? So these are the business insights that can be generated from your machine learning. So that's what is very interesting. Okay, now let's start with today's agenda. So last time I think we paused after.
So, so
Yeah.
one second. So, where is the machine learning come into the picture? I understand this whole thing, like there are different patterns.
Yeah. So how did you
So,
identify
what
the
is the
pattern?
specific?
I mean, when you are giving the expiry, I mean, forecasting accuracy is changing from 80% to 60%. Your model is giving me the probability of expiry, right? How did you do that? You didn't check it manually, right? Obviously, there are lack of data points. You didn't check it manually. What is my probability here and there? So you did a model. Yeah, you fit a model. Now you're inputting. So you talk to your business. You talk to your logistics. They say, Okay, Shubhadeep, let's say if I can produce this in Asia, I can drop my lead time to from 60 days to 30 days. Can you tell me what will be the cost benefit in that sense? So I'll tell, okay, wait, let me feed that into my model. So I take Johnson's baby product. I will just, let's say, Johnson's baby powder. Then I feed in the lead time. Earlier it was 60 days. The model had trained on 60 days. Now I fit in 30 days. I want to predict what is for 30 days, and then the probability of expiry will be predicted, right? So that's where the machine learning comes into picture, right? The patterns. So all these things, the important variables, the combinations of variables which lead to expiry, what is the probability of expiry, the quantification, right? The quantification of that probability is much very important. Anyone can tell me that if I have a very huge lead time, if I have a very low shelf life, and if I have a very what else, other factors also, let's say very bad forecasting, let's say I'll lead, it is tending to be probable, more probable to expire. But that's not what my point, right? My point is how much. I mean, I need to quantify, right? That how much I need to, when I do a debottlenecking of the business, I need quantify numbers, actual numbers. What will be the change? For example, if your shelf life is too low, and if your lead time, even if you dip it from 60 days to 30 days, if your shelf life is lower than that, then it will not make any sense. You'll still be having a probability of expiry of 1, right? So that's where your quantification becomes very important. And what was the other thing I was saying? I forgot something I wanted to add.
So
Yeah.
this is the kind of a regression learning, right? Because
No, probability of, see,
continue.
whenever you're trying to see the probability, right? So uh, probability is also always associated to classes, right? That's what we have learned, right? Probabilities from 0 to 1, it's always, it's a restricted zone, right? It's not a regression problem. A regression problem is an infinite zone of numbers, but a probability is a restricted zone of 0 to 1, right? It's always classes. So for example, I say that probability of expiry greater than 0.2, I'll consider that it will expire. If it is less than 0.2, I'll consider it as not expired. So this is a classification problem. I'm telling you in terms of probabilities. That's what we have learned, right?
Okay.
Regression problem is a continuous variable. Classification problem is classes, but behind those classes, we always have an associated probability.
Hmm. Okay.
Okay, any questions on this?
A quick question. How do you prep the data? See, the first statement you gave was garbage data, garbage in, garbage out, right?
Correct.
But how did you prep the data? Is that something which Johnson helped you guys, or like,
So,
or you use some kind of tools?
correct. So every company will have a database, right? So for example, Johnson's will, the this was for Asia Pacific market. Okay, I mean markets. I mean where the SKU is being sold. So this Asia Pacific market will have all the data in its SAP database, right? The ECC, what we call the business warehouse. So it contains all the data there, right? So now you have large number of data points. So first you need to understand what is the time frame you're going to take, whether you should take last 3 years, whether you should take last 10 years, whether you should take last 2 years. First of all, you have to decide the time frame. Now generally speaking, if you are not doing a time series analysis, for example, here we are not dealing with a time series analysis. Time series analysis is basically a forecasting means depending on your historical trend, I mean historical months of sales, I'm predicting the next month of sales. This is a time series. But this is what I did. This is not a time series per se, right? It is more of a cross-sectional data. We will not get into too much depth what is cross-sectional and what is time series. But cross-sectional is more of, let's say, it's a snapshot, right? It's a snapshot of every month. So month of January, May, February. So time frame was not a very big concern for me because I wanted to find out patterns, right? So patterns can exist in any month. So if I have at least 2 years, that is sufficient. But if you are doing a forecasting exercise, then it is very mandatory for you to have at least 3 years. so that you can understand the seasonality, the trend, and the other components. Okay, don't get too much confused in that. What is time series? Just I was stating since you asked the question. Now, first you decide the time frame of your data collection. Then you move forward and take the variables. Now, for example, let's take okay, let's take line efficiency. Okay, or let's say an equipment efficiency. There's an equipment called a boiler. Its efficiency. Do you really think that the boiler efficiency is going to affect my expiry in inventory? No, right? So that's where your business knowledge comes in. You cannot take all the data present. There's a lot of like petabytes of data in Johnson warehouse, right? A business warehouse. So you need to understand which will be the components of variables that could likely be affecting your inventory, right? So that's where your business sense comes in. Then after you take all those variables, right, then let's say you have taken 20 variables. Now, does really your 20 variables make sense? What does your data tell? That's where you do a feature importance, like we saw last time, right? A feature importance plot, and see which are the variables that are important out of these 20. Let's say 7 or 8 come as a answer that these are the variables that are important. After that you when you get that number, then you fit your model on those 7 variables. So you started with 1,000 variables, you got your business sense into picture, you got into shortlisting of 20 variables, then you went on to shortlist 7 variables. However, there are certain cases when you don't know absolutely nothing about the business, right? So even if you could take 1,000 variables, your computational power will increase, but your data, I mean your model, will still tell you out of those 1,000 variables, these 7 are important. So my model is not constrained by the number of variables. Remember that my model can tell you any number of variables out of any number of variables, whichever are important. So but it's all depending on the computational power I have. I cannot feed in 1,000 variables in my 8 GB machine and process and boosting algorithm. It will take. But if you have a server, you have a multi-core server which is having 32 GBs of RAM, then I mean it doesn't matter. You can take 1,000 variables and do a feature importance. Still, it will give you those 7 variables which I got after shortlisting 20.
Yeah, see that I understand, right? But say, let us say you were saying like say one year of data, for example, right? Let us say,
Correct.
but we'll take the future of the lead time, right?
Yeah.
So let us say there was a big monsoon or hurricane, whatever it is, and there was a delay in the lead time or the transportation,
Correct.
right? So
Correct.
this 1 year of data has that defect data.
Correct.
To put it correct. But if you say taken a 5-year data, you might not have that defect, right?
Correct.
So how did you basically figure out, okay, this might be a defective data or not?
So that's a very interesting question. That's a good question, actually. In fact, so that's where your data cleansing comes into picture. So whenever you're starting to fit a model, as we said that if there are outliers, right? So your hurricane cannot be over the whole year, right? Maybe 2-3 months it was there. Your lead times were very high. Your service levels had dropped. That's where you keep that data apart, right? You don't take that data. That will skew your model, right? But in your 5 years of data, that's correct. You may not have that defect, but there still will be disruptions. And when you are operating in a such a large company, there will be disruptions here and there, right? So whenever you see an outlier, whenever you see a statistically bad data, you will remove that. You don't have to. So for me, I knew that whenever the disruption has occurred. But for example, if you're just a data scientist and you don't want to go into business and all, and you don't want to do any research, then just go and find the outliers and remove them, right? If the data is too, I mean, if your data can be removed from those outliers, it can be separated from that, you're good to go. I mean, it cannot be that your hurricane was totally for the whole year. Then then your whole 1 year is an outlier. So that you cannot handle. That's when you need more years of data. But that's a very unlikely situation where your hurricane would exist for a whole year, and the whole year becomes an outlier of the business for the business, right? But that's an unlikely scenario.
Yeah, but how do you find the outliers? Like, do
Okay,
we
so
have
how do we find?
more like I see like a visually see the data and manually tell, okay,
No,
this
no,
is
no.
a bad set of data, or like, do we have any kind of a process in place in machine learning which basically tags the data as outlier data?
Yeah. So, for example, the first and the most basic form of outlier is, so you have a median, you have your first quartile, your third quartile. So whatever is beyond your 1.7 times your first quartile here and there, like, okay, let me draw this. Wait, I'll just go into my iPad and I'll draw this. There are actually many ways to just a sec.
This is where I think most of the people will be struggling, right? So that only I just wanted to raise this
Yeah,
question.
yeah, yeah. That's what I'm saying. It's a very good question that needs to be addressed, and maybe we can, in the upcoming session, we can have something on that where we can have a session on how to remove outliers. So basically, um, there's something called a box plot. Okay, so now I'm explaining you this visually, but you may not need to do this visually. R will, or sorry, your Python will automatically handle. So your data distribution, okay. So your data distribution can be anything. Can be normal, it can be Poisson. So there are many different. So this is exponential. So there can be many distributions. So there is one thing that you um, know the distribution. First, you know the distribution, and that distribution is can be known from business knowledge or can be known visually. But this is a tedious task, right? So what you do is basically whenever we are trying to find a median, right? So let's say your numbers are sorted 1 to, let's say, 100, and your 50 is the median. Okay, so your first quartile is the 1/4 region, your third quartile is the 3/4 region, and so basically four parts it is divided: first, second, third. Sorry, I'll just divide it: first, second, third, and fourth. So whenever you're sorting, so let's say 1 to 25, 25 to 50, 50 to 75, and 75 to 100. I'm just taking an explain, just taking a basic example. Now, this is called. I mean, this is you have just arranged in ascending order of sorting. Now, suppose there's your data is being arranged like this. Now, you have something, let's say, beyond this, right? If you have something beyond this, so let's say you have just one point in, let's say, point 1 here, and the rest of the frequencies of your data lies here. Okay, now if there's a single data point or a very or a less frequent, I hope you understand the frequency term. So how the number of occurrences of that bucket. So 1 to 25, how many it has occurred. 225 to 250, how many it has occurred. So suppose there's a data point which has just occurred once and it is very far off from your normal histograms. I mean normal frequency data. So this is an outlier for your data, right? For example, in a normal distribution, if you could see a normal distribution, if I say that it is normally distributed, something beyond this point, so this is the normal distribution, right? This is the normal PDF. So I can see that something which lies beyond these, let's say 2 sigma, is a point which is kind of an outlier for me, right? It is not representing the whole population. Now, this definition can be dependent on the user. Some user can say this can be 3 sigma. Some user can say it is 4 sigma. Some user can say even it is a 6 sigma. You may have heard 6 sigma processes, right? So 6 sigma process like an airline industry. So the number of accidents per miles of air travel, right? So that if you follow that, there will be very little. That will be a very little number, right? So these uh, industries operate in a 6 sigma. So for them, 6 sigma is not even an outlier, right? 6 sigma is their normal operation. So this definition of sigma will depend on the business. So for example, for me, I would say in a FMCG industry, if something is lying beyond the 2 sigma band, I could say, for example, your lead time was, let's say, 40 to 100. Okay, and this is 40 to 100 is the 2 sigma band, and if something is beyond 33 or something is beyond 120, then I would say 120 or 33 is an outlier for me. However, some other very small FMCG which has a very high variation, he would say no. Or maybe let's say some FMCG which has a very low variation, let's say in a airline industry, an airline industry would say if I experience even one accident, so for them it's let's say 0.0003 accidents per year, let's say. Okay, so for example, if they even experience one accident in a year, that will be kind of a outlier for them, right? So it depends on what industry you're working on. So that's why data science is not independent of business. It is a kind of a addition to your business. So you have to know that which is the normal operating range of your system, and what is your normal characteristics, what is the distribution. So normally Python will automatically remove the outliers based on the assumption of a distribution, right? Or it can do a very simple thing that it arranges by the median. And if it sees that it is beyond some quartile, for example, let me show you if I can here. Let me show you outlier removal in Python. See, removing outliers using standard deviation in Python. That's what we did, right? We assumed um, a sigma of 2. So that's exactly what I was telling about, right? So I assume that this minus 2 sigma and 2 sigma, I can have the band anywhere where I want to specify, right? I can have a 3 sigma process. So uh, remove outliers using normal distribution and SD, right? So it will assume that it is following a normal distribution and remove, right? So this is the code where you can simply remove your outliers, and it will remove. So let's see another thing. Detect and exclude outliers in pandas data frame. Okay, so you have a data frame. You see here, you define 3 into data standard deviations. This is the standard deviation of this. So whatever, if my data is beyond the 3 standard deviation, I consider this as an outlier. So this minus is basically remove them. Okay, so this one, right? So you basically get an essence, right? So it depends on most of the times you assume a normal distribution. Okay, but if you don't know, then if you don't know the distribution, then you have to kind of plot it visually and see it. But even though it doesn't follow a normal distribution, just take the standard deviation. Whatever falls beyond 3 sigma here and there, you could consider that as an outlier. Is that clear?
Yeah, that was useful. Yeah,
Yeah.
thank you.
Yeah. Thank you so much. Okay. So, okay. Any other questions from anyone else, so that we can start with today's lecture? Okay. So,
one question, but there is something outside. So
huh,
now you have all this tools, right? Sorry, you have all these tools of say uh, data, robot, Watson, all that, right?
yeah, yeah, yeah.
So is learning all this will help in that, or how it is going to play around?
Okay, and
You know what
now,
I'm doing?
yeah, yeah, I got it. So for example, let's see how we can answer this. IBM Watson is kind of a niche machine learning model that they have developed for their own. Now, let's say even if it becomes a reality that it can predict everything, which they claim that they can do in, let's say, 20 years or 15 years from now, you still need machine learning engineers or data scientists to maintain it, right? Because every time that whenever we have discussed modeling, right, we have already always said that it's never a static process, right? It's not that you build a model and forget it. You have to keep on updating every time. Okay, there will be today as we speak. Go 1 month later, there will be a different new model that has come up in your machine learning technique. For example, deep learning before 2011, there was nothing called deep learning. Right now, your Siri, Apple Siri, your Google, do they call Google Home or something? I don't know. Your Amazon Alexa, all these are deep learning, text to sorry, voice to text processing. So everything is deep learning. 5 years prior to this, no one had imagined that deep learning will cover this. So who knows? I mean, what will be the next big thing in machine learning? But you have to keep your pace with it. So there will not be a perfect model that is going to fit everything, right? So you have, as a data scientist, you have to know all the models. You have to keep on updating yourself, that whatever model comes in your way, you have to learn it, you have to understand it, you have to tune it, you have to keep on thinking how we in ways we can do a better way. Now IBM Watson is kind of a machine learning, let's say a very uh, mm, I would say a very complicated version of a, or very, let's say, I'm not getting that word, a very complex, okay, let's put it, I'm not getting that word right now. So it's a very complicated model which has a lot of machine learning models, and it tries to predict a lot of things, right? But it's not that IBM is going to send IBM Watson to solve your business problems. If even if they have it, they will, let's say, they're going to sell their service for millions of dollars, right? That's how they're going to operate. So for example, if it can detect cancer, it's going to be very huge. They're going to charge huge money for that, right? So it's
No,
not that
no, sorry.
if yeah.
This they're basically giving a service in their cloud. Basically, it is not that costly, like $1 million, but they do give in the cloud. Yeah,
No,
just
no.
wanted to let.
Okay, so I didn't. I'm not aware of that. I mean, do they allow you to use the IBM Watson model as per se, not the server? Do they allow the IBM Watson model to be used for your business? I don't know. I am not aware of that.
Yeah, basically, they're exposing their APIs, so we can basically use their APIs out.
Okay. No, see, for example, Google's TensorFlow is a API, to implement deep learning models, right? So, are you sure that those models are already running in the background, or you can build your model using an IBM Watson API?
Uh, Basically, I think they have a few models which they've built, which we can use. Like for the machine learning, they can use. But you can also build a model. You can basically write your code in Python and basically put it into there. This thing.
Okay, okay. But however, I mean, if it, let's say I'm not aware of that, if they are allowing you to access very complex models, because I don't think they will be patenting it, and every business cannot be using their own. For example, if they develop a cancer detection model, they will be patenting it. But I'm not
No,
sure.
no, no, no. They're not giving you the business model. They're not exposing the business model. They're exposing, like, for example, the linear regression, right? So
Yeah.
they have some GUI kind of a linear regression where you can use that.
Correct.
right?
So it's kind of similar to what we are doing, right? It's kind of similar to the
Yeah.
packages, right? The packages are inbuilt, right? You're not doing anything to build your linear regression from scratch. The linear regression per se exists as a package, as an it's not an API, but it's exists as a package. But you are using that package to implement in your data, right? So okay, I'll just read about IBM Watson and get
Okay.
back to you,
Sure.
and try to answer this. I mean, I'm not very sure of what they do.
Okay, got it.
Yeah, but for example, so there's something called NVIDIA's. They have launched a new platform for deep learning, TensorFlow. They have a kind of a Google's TensorFlow. It's kind of a API to implement your deep learning model. So Python, as such, it's difficult to implement deep learning models. So Google came up with this TensorFlow, which says that why don't you use our API, which kind of structures your data in a very different way, and then you can use a deep learning models more efficiently and more in a very better way. And that's how Google, but will not. I mean, they are not allowing. They'll not allow you to see their model and use that as a text to speech to implement in your business. So at any point of time, you have to create your own model. You could be using packages, could be using servers, you could be using APIs, but at the end, you have to understand your own model which fits your own business. For example, the way the project that I did, no one has used same kind of approach or a similar approach for their. So Walmart has a different approach to their inventory. They call it inventory freshness. PNG has a different way. So every company will have a different way. Anyways, we'll cut to that chase later. I'll just read about that. I'll get back to you guys. Okay. So let's start for today. So last time we ended up in something called clustering. Okay, so I'll restart from where we left yesterday, last time. So let's see. So I would say we have till now done a lot of supervised learning, right? So what is supervised learning? Can someone answer? Can I get some answers?
Yeah, where we tell the model the different patterns, and we are guiding the algorithm.
Not very specific. I mean, you gave an answer, but it's not very specific. It's a very simple one-word answer. I mean, not one sentence answer. What is supervised learning?
The
Anyone?
data is supervised, or it is a fixed set of data. It is not like a random data.
Um,
Supervised learning if there is y has been given
exactly.
for
That's
the
it.
given
Sorry.
x.
Yeah, exactly.
That is
Perfect
the
answer.
supervised learning.
Why is there? I mean, Krishna, I think you were meaning this only, that it's not random, and it's a particular set of data. I think you were meaning this, but I think Sunil is right on the spot. Why is there? I have a why that every x element, I mean every row has a y associated with it. That's a supervised. No other definitions I want in supervised learning. Only one definition. Every row has a y associated with it. That's it. Okay, Krishna, you may be meaning this, but your answer is not. I mean, I think I could understand that, but if you answer this to someone else, he may not get the point what you're saying. So, random data and fixed data is different, right? Random data is like you're picking up random sets. Fixed data is like you're feeding the whole set of data. That's different. Supervised learning is basically that your every associated row of data, every x, I mean x1, x2, x3. So all the features, whatever is there, they have a y associated with it. Someone has gone through the pain of collecting the y for you. That's very straightforward answer. Okay, now, so the other would be unsupervised learning. Now, can you guys answer this? This will be very straightforward, right? What is unsupervised learning?
If there is no y,
Correct. So someone forgot to mention the y. Someone has collected data on x, x1, x2, x3. Someone has collected, but they forgot to mention the y, or forgot to collect the data y. They forgot either, or you don't have any y associated with it. You don't know. Okay. So this is a very important. Don't forget this, guys. This is very basic of machine learning. Okay. What is supervised learning and unsupervised learning? Okay, so supervised learning, we have seen a lot of algorithms. Okay, give me all the names of algorithms we have seen. I want all the regression algorithms. I don't want errors in this answer. All the regression algorithms, give me by name.
first one was linear regression,
Perfect.
then multilinear regression, then
Awesome. Yeah. I want others to pitch in also.
no, but just I'm classifying those are classification algorithms. Otherwise, there are 9 algorithms we have covered.
I want the regression algorithm. That's why the answer is not straightforward. That what are the algorithms we have learned. I want the regression algorithms, which can be used for regression.
Polynomial, then lasso,
Correct.
and then
Yeah, last reach.
Correct. Then guys, what about decision trees, random forest? Didn't we do the Boston housing?
Yeah, we do, but I think so that were related with classification, isn't it?
How can it be classification? What were we predicting in Boston? We were predicting price, right? Price in the
Yeah,
continuous variable.
yeah. Sorry, yeah, I remember. Yeah.
Yes.
Then yeah, that was again k and then problem, k nearest neighbor problem.
Yes, number was also regression.
Then
Very good.
Logistic regression.
then deep for then that was deep forest, I think so. Yeah.
Okay. Someone said logistic regression. Logistic regression is not a regression problem. It's a
So
classification.
that is classification
Yeah.
problem.
Guys,
Because we are
you
using
have
sigmoid
to
function
revise. If you don't revise,
for your one.
it'll the feed will not be proper, right? I mean, uh, right now we are on the 5th week. We need to have ready answers on which is a regression problem, which is a classification problem, right? I want everyone to be like having perfect answers on this. What is a regression problem? What is a classification problem? Which of the algorithms can be used for regression? Which are the algorithms which can be used for classification? There should not be any confusion on it. If you have confusions, ask me. But I don't want you to end this session, end this course, and be confused with what is a regression problem, what is a classification problem. Think on your own. Can a decision tree be used for a classification? We discussed it in terms of probabilities, but then we also applied it on a Boston dataset. What were we doing in a Boston dataset? We were predicting the price, right? So if you're predicting the price, which is a continuous variable, this means decision tree can be used for a regression problem also. Random forest, similar thing. Whatever decision tree can do, all the other algorithms which were tree based can do the same thing. It's not that boosting, which is, or random forest, which is building multiple trees, cannot do what decision trees. They were improvements, as we discussed, right? They were improvements of decision trees. So if a decision tree can do a random regression and a classification, why can't a random forest do, right? And there's nothing called deep forest. So
Yeah, I agree. Sorry for that.
yeah,
That is
don't
random forest.
mix up the models. Next class, I'll ask you, each one of you, the algorithm and what it can do. Okay, I want perfect answers on that, because I don't want you guys to have end this course and be confused with what is a regression, what is a classification. Okay, again, I'll ask particular algorithms. Tell me whether it's a regression and classification. Um, can a lasso do a classification problem?
Yeah, I think it can do both.
No,
A lasso cannot do a
No.
classification problem.
no.
Okay, a lasso is a regression problem. See, okay,
Yes.
if you guys are having confusion in this, uh, let me make it this very easy. Uh, okay, whichever models we have discussed probabilities. Okay, those are classification. Did we discuss probabilities in lasso? No, right? We didn't discuss probabilities in lasso. We didn't discuss probabilities in regression. We didn't linear regression. We didn't discuss probabilities in ridge. It means whichever models we haven't discussed probabilities, that model cannot deal with a classification problem. Okay, wherever we have discussed probabilities like decision trees, random forest, boosting. Okay, keep this. I'll make this simpler. Okay, tree based algorithms, keep it very in a different set. Okay, your decision tree, random forest, gradient boost. Okay, these are a different tree based approach. So these can do a classification and a regression both. Okay, now the other things where we have like linear, ridge, lasso. Okay, these can only do a regression problem. Okay, classification is KNN. Okay, I'm not writing these because these are common. Okay, so a KNN can do a classification, KNN can do a regression. A logistic can do a classification, but a logistic cannot do. Okay, I'm mentioning this specifically, cannot do a regression problem. Okay, then what else did we learn? Right, we have covered all, right? SVM, yeah, SVM. Can answer anyone answer about SVM?
That's classification, right?
SVM can actually do both. Okay, so I can pardon you that because we didn't discuss regression on that, but SVM can do both. Okay, so kind of think like this: more advanced your models become, they more become more ambidextrous. Okay, I mean it can do both. The let's say the older the models, linear regression, ridge, lasso, these are very old models, right? And we also learned that in the first, so they could only handle one at a time. So these could handle only ridge regression. Logistic can also only handle classification. From KNN, things become more simpler. KNN can handle both. All these will handle both. Deep learning can handle both. Okay.
What about neural network?
Yeah, deep learning and neural network are basically the same thing. So deep learning can handle both. Okay, but don't get confused on this. Okay, if you have any questions, ask me on this. But don't end this course and not be able to, decipher the fact that which models can solve what. Okay, so we have seen supervised learning. Okay, now coming to unsupervised learning. Now unsupervised learning unfortunately doesn't have so many, unfortunately or fortunately, whatever you want to say, it doesn't have so many models. Okay, it's kind of very simpler, and the main reason behind it is because basically because if you don't have your why, it is basically no sense of analysis, right? What do you want to do with a data set which doesn't have any meaning of it? But there are certain business cases where you cannot have everything. I mean, the customer will not tell you every time about its behavior, right? You have to understand traits from what you know. So, for example, let's say, okay, let's take this example. Uh, when a customer is coming to your store, okay, let's say a Walmart store, so Walmart has installed cameras. Okay, so it is finding out patterns. So for example, how the customer's hands are moving, how he is looking in the bottle, how he is like checking the price, what's his facial expressions on different brands. So does he see a Johnson & Johnson product with a frown, or does he see a P&G product with a smile? I mean, all these things it is kind of trying to see from a camera or a video cam, whatever. The customer is not going to tell the Walmart store manager, see, okay, he can tell if he didn't like a product, but he's not going to specifically tell everything about every single product he has seen, right? So if he doesn't like a PNG product because it is highly priced, he's not going to tell the Walmart, oh, I didn't buy because it is high price, I'm buying this. It may be a case, but it's not always true, right? So sometimes you cannot avoid a unsupervised learning problem. It is going to exist in your data, and you have to do something about it. You just cannot throw it away, right? So that's where your unsupervised learning picture comes in. And later, when you see, right now all the research is going on unsupervised learning, right? Supervised learning, most of it, people have kind of uh, done a lot of research and kind of figured out what to do. But unsupervised learning still is an open book. People are still struggling to what to do with unsupervised learning and all. So okay, so this is what I wanted to say. So unsupervised learning for right now, since we not deal with very hi-fi unsupervised learning models, a very simple model is called a clustering model. Okay, now clustering is a very simple task, very simple task. Okay, nothing doing here. I have, let's say, I have make it in black. I have data points. I don't know anything about why. What is the y associated with each of the data points? My manager has told me to do some kind of an analysis. So I kind of do an analysis. Okay, I say this is one group of customers and this is one group of customers. Let's say let's say these are car buyers, and people are saying price and power. Okay, so these are the customers who are willing to pay a higher price for higher power. So I can term them as automobile enthusiasts. Okay, people here, they don't give too much um, concern about so they want a lower price, and they don't have any concern about the power, right? So they are in the left lower bottom side. So these can be termed as price conscious customers. Now, what do you do after this? This is something which you have decided, right? No one told you this. Now, what you do is, when you get a customer out somewhere from this group, you present him cars which are, let's say, high power, and if you get some customer who is from this group, you give him price of cars of low price. You show him cars of low price, right? So I don't know the common cars in US. So for example, in India, Maruti is kind of a brand. Maruti Suzuki is kind of a brand which has, you know, let's say, established itself as a car make manufacturer, which is more of a price conscious people. Okay, so they don't want to have lot of power. They don't want to have. They can have do adjust with average features, but price is more important, or mileage is important. But a person who is buying, let's say, a Honda, this guy, he's more concerned about power, or he is more concerned about price. I mean, I should get the right power for my price. Okay, so it's a very simple example. This doesn't make much business sense as such, but there are certain instances where you can identify. So, for example, a new customer, he says, I want to buy a car at, let's say, which is $100,000. Okay, I think it's very huge. Sorry, $50,000. So you say, okay, I think this guy is kind of a power oriented guy, so I'll show him, let's say, Honda cars or whatever. New person comes, you ask him what is the price range you are looking. He said, I just want let's say a $15,000 car. Oh, okay. Then it means you are not interested too much in power. Let me show you a Maruti Suzuki car. Okay. So this is how you kind of do deal this with business. Now there can be multiple dimensions, right? Right now I've just presented you two dimension, price and power. It can be price, power, color, mileage, body structure, uh, features, X number of things can be. Then for here it is very easy for you to say because there are only two dimensions. When the dimensions become 1,000 or 10,000, then it's very difficult for you guys for you to understand. That's when the clustering comes into pictures. For example, in 1,000 dimensions, this is the group. Let's say there are many dimensions. So you ask this guy the price. You cannot ask that guy 1,000 dimensions, right? So you ask the guy about his price, his power, and features performance, and you can approximately tell that this guy belongs to this group, and hence you can market some particular brand you want to you think that the customer will buy. So how does this algorithm work? This algorithm is very simple. So this is the data that is there. Your algorithm will start with the first step is initialize random clusters. Okay, initialize random clusters. So I take a random point from my data, let's say, and also the number of clusters also the user has to tell. Now this is very irritating, right? Oh, I am telling you everything. I want k is equal to 3 and k equal to how many clusters I need. That is also I'm telling what you are going to do. But bear with me. Let's understand this algorithm and then we'll see how it helps. So initially you have to tell the number of random clusters. Okay, so this is one cluster. So you say 3. So this algorithm is going to randomly assign. Okay, randomly assign cluster centers, not clusters, cluster centers. Okay, now after this is done, each point will be calculated a distance from the center. So for example, uh, all the points are calculated distance from here. Similarly, all the points are calculated the distance from here. Sorry, not this. Okay, and similarly all the numbers are calculated in distance from here. Okay, now this point, let's say, will have three distances. I didn't mark the green one blue, one black, one green, each for the three clusters, right? Now this this point is closer to this cluster, so it will be grouped in this. Similarly, let's say this point, it also has three distance, so the least one is here. It will be grouped here. So kind of after one iteration, your, let's say, one was a let's say the top one was a green cluster, the bottom one was a black cluster, and the this one was a maroon blue cluster. Okay, so it will have some data points, this will have some data points, this will have some data points. Okay, all the data points will not shift. I think I didn't make the diagram properly. The data points will not shift, they will just be grouped. Okay, the data points will not shift and come inside the group. So basically this boundary is made. Okay, so this boundary is made and the data points are grouped. Now, so what was the second step? You find out the distances and group them in the clusters. Now after you do this, the interesting part is the cluster centers will change. the first assignment was random, but after you got new products in, new points in this, the cluster center will change. The center is basically the mean of the, so this, if this x1 and x2, so every point will have a x1 x2 x1 x2 x1 x2, every point will have these values. So basically take an average of this and take an average of this. So the center, cluster center, will be the average of all in that cluster, sum divided by the number of points in that cluster. Okay, and similarly y is the number of points in that cluster divided by, so we get this, right? So this is the cluster center. So the cluster center will change. Now again you do this, whatever you did on the top, you kind of do this again. So the distances will now be calculated from the new cluster center. Okay, and this procedure is iterative. Okay, so every time you do this, so when will the algorithm stop? The algorithm will be stopped when your cluster centers now don't move. So your all the data points have actually been classified in that cluster, and now they don't move because the new cluster center which is coming, and again it is calculating the distance, and then again assigning the points, and then again calculating the cluster center. This is again the same, so it's not moving. That's when the algorithm stops. Okay, so do you guys understand now? Any doubts you have?
But this is a costly operation, right?
Yeah, it's quite costly. You're correct. It's very costly because every time you're trying to calculate the distances from each of the clusters and reassigning it. It's a costly operation. You're correct. Yeah. Sunil, I saw that you're not very clear on this. Can you just specify which part you're not clear so that I can
Yeah.
revisit that?
So basically,
Yeah, go ahead.
yeah. So it seems basically we are taking points, assuming we have x1, x2, x3, 3 points,
No,
and we have not been given any y.
No, not 3 points. These are the dimensions. These are not
Yeah,
points.
dimension basically. I mean not points, dimensions, predicators.
Yeah, predictors. Yeah, predictors.
Yeah.
Yeah.
So these are predictors. So x1, x2, x3, and many row we have been given,
Correct.
and we don't have any y.
Correct.
So using k nearest neighbor problem, and how we'll decide these points basically, that is my question. Visually we can see, okay, these are the points.
Where did k nearest neighbors? This is called clustering, right? Where did k nearest neighbor come?
Yeah, no, so means, okay, so forget about those. So from where these points came, I have x1, x2, x3 predictors.
Okay.
So means how we are drawing this point.
This is your data set, okay? Simple data set, nothing complex, right? A simple data set having
Yeah.
2 predictors and 100 data points, right? Okay.
Okay.
Now I tell you to plot these data points. What will you do? You will take the x1 here, x2 here, and you'll plot 100 data points, right? So your data points will come here, right? These are the 100 data points. You have just plotted, right?
Yes.
Any confusion till now?
No, it's okay.
Okay. Now ask me. Now tell me, what were you asking? Where will the points come? What does that mean? What does that question mean?
Means our algorithms will detect all the points.
No, I have not done any
And
algorithm till now. I have not done any algorithm till now. I have just plotted the points, right? Nothing.
Okay, so we have 100 points on this 2D.
Correct. Perfect. Now I said I want to prepare 3 clusters on these 100 data points. Okay.
Okay.
So I run a k-means algorithm. So my algorithm, what will do is, first step, let's go back to the first step. Initialize random cluster centers. K equal to 3 I've told that I want 3 clusters. So initialize random 3 cluster centers. So for example, I take this point randomly, okay? This point and this point. Okay? You getting it?
Yeah, correct.
Awesome. Now,
And no, I think now I got this. We'll keep doing until our points are not moving.
correct. Perfect.
I think I
Amazing.
got it. Yeah.
Yeah. So you kind of have a boundary like this, kind of have a boundary like this, and you kind of have a boundary like this. So these are the 3 centers. Is this clear?
Yes.
Okay. Awesome. Then, now, can anyone tell me? I mean, I would say this is a very tough question, but can anyone answer this? I'll be very happy. What can be the objective function here? What were we trying to reduce? Every algorithm has an objective function, right? See, in tree based, we saw Gini index. In regression, we saw RMSE. What can be the objective function here? It's a tough one.
The minimum distance between each points, right?
Amazing. Within the cluster. Amazing. That's an amazing answer. So I'm trying to reduce the variance, or let's say within sum of squares in this cluster. And the other thing that I'm trying to do is maximizing the distance between any 2 clusters. So within the cluster, my variation should be minimum, and between the clusters, the variation should be maximum. I mean, the clusters should be well separated from each other, and within the cluster they should be more coagulated. Is this clear to everyone? I think that's an amazing answer that I think Krishna gave. Yeah. So is this clear to everyone?
Yeah.
Yeah. So now, if this is my answer, I mean, this is the objective function, and let's say I am trying to reduce the within sum of squares, right? So my within sum of squares will kind of reduce as we increase the number of clusters, right? So as I go on increasing the number of clusters, my clusters will become small. Let's say I want to have 10 clusters here. Okay. So this one, like this. If I take out 10 clusters, your within sum of squares is obviously going to reduce, right? Because you are having less number of points within the cluster. Okay. So so can anyone tell, although we don't have a y here, but keeping an analogy from your previous lectures, what we are trying to do, is it an overfitting we are trying to do, or an underfitting we are trying to do when we are bringing in more clusters?
So overfitting.
Oh, amazing, Sharad. Overfitting, yes. So as we go on bringing in more clusters, I try to reduce my within sum of squares to the least possible, but then I'm trying to overfit. Okay. So there's something very important called the elbow joint. So typically your cluster graphs will look like this. Okay. So at a particular cluster point, and let's say k equal to 5, this joint is there, and then the dip will be very slow. So after this, you don't consider, I mean, you don't go after this. You consider this point. So your k is equal to 5 is your optimum number of clusters. This is your WSS. And this plot can be seen in Python. This code is very easy, and this plot can be seen. Okay. So this is called the elbow joint. and beyond your elbow joint, you do not go and try to overfit your clusters. Is this clear?
Can you explain again one more time? I missed it.
Which part? The within sum of
Elbow joint.
elbow
This
joint. Okay.
elbow joint.
Okay. So what I was trying to say is, as you go on increasing your number of clusters, you are bound to decrease your within sum of squares, right? It will try to slowly merge. But
Correct.
how will you find the optimal number of clusters, right? So this is called an elbow joint. And every typical cluster problem will have this kind of a typical elbow joint that useful. This is a WSS within sum of squares. So let's say at k equal to 5, the elbow joint comes. So you can take k equal to 6 also, not a very or k equal to 4 is not advisable. So kind of where the dip is now, very smooth after which. So you can take this as an optimum and say that k equal to 6 is the ideal number of clusters that my data should have. Okay.
And I believe that there will be automatic algorithm to get this right.
Yeah. So normally what you do, this is a separate part. So k-means will be an algorithm where you specify the number of k, and then you just I think, yeah, that's the number of initialization. So n init is a function or a parameter where it says, so this random assignment, see, when this random first step where we saw that we initialize random cluster centers. So if your n init is equal to, where did I write n init? Yeah. So n init, where basically what we see is n init if equal to 1. So what it will do is, just one time it will assign the random clusters and just start. Okay. But if n init equal to 10, then 10 times it will assign and then take a mean. So this is more smooth. You don't want just the computer to just assign first randomly one time and then start the algorithm. So normally it's kept at 10. So you want the machine to initialize 10 times and then take an average of it. Okay. And then you just have the
10 minutes is 10. Sorry, 10 minutes is 10 iterations.
no 10 not 10 iteration, 10 initialization. So this first step
Oh,
itself,
so basically, it tells first time I plot it, I do all this thing, get a number. Then second time again, I try to find the plot the center, do the same thing, right?
no. So what it does is, so for example, you're assigning a random center in your first step, initialize random cluster centers, right? So this is our n init equal to 1. So you just assign and then start your algorithm and start the assignment. But sometimes what happens is, so for example, the interesting part is, let's say uh, your actual clusters, okay, your actual clusters are here. Okay. Now, for example, your algorithm has assigned a cluster center here and a cluster center here, then you'll end up kind of getting the same clusters, the actual cluster. But for example, if your cluster center is assigning somewhere here and another here, how will the clusters look like? The clusters will look like this, which is not the actual one. So you don't want your algorithm to just go and assign randomly once and do start. You at least want the cluster kind of 10 initialization. Let's say 10 times it has assumed a random, and then basically take an average. Again 10 times it has initialized, and then you take an average, so that the cluster centers. So the initial points will also determine your final clusters. It's not just the number of clusters. Your initial point, if it is way too off from your original clusters, your final cluster, what you will get is also will be way off from the actual clusters. Is that clear?
Yes, yeah, thank you.
Okay. Any questions? Okay, so everyone is clear then? Okay, perfect. So, although this is not in the scope of our course, but since we have um, done clustering, I will also try to, what is the spelling of hierarchical? For, pardon me the spelling. I don't. What is the spelling of hierarchical? Yeah, I think I'm correct only. Hierarchical. Yeah. So hierarchical clustering is it's it's again a form of cluster. So this is called a k-means clustering. Why K because of your number of clusters, means because you're always taking an average. Okay, you're always taking an average. So where did I show that? Yeah, so here you're taking the mean, right? So that's why K from the clusters and means from the actual operations. So hierarchical clustering is a different kind of a clustering algorithm wherein it's a little, so something called a dendrogram. Okay. So what you do is you start with all the data points. Let's say you have 100 data points. You start with all the data points and slowly start moving, grouping them from below. So for example, these are two very similar points. So you kind of similar points in terms of distance. Okay, Euclidean distance. Euclidean distance, is everyone clear about what is Euclidean distance? Anyone has a doubt of what is Euclidean distance? Does anyone know about what is Euclidean distance? Okay, so I'll just share. So for example, your point one, x1 is, let's say, x1 are the features or the predictors. Okay, so x1 is 5 and x2 is 2, 10, and this point 2, x1 is 7 and x2 is 8. So what is the Euclidean distance between this? This is 5 minus 7 whole square plus 10 minus 8 whole square and 100. This is the Euclidean distance. Okay. Yeah. So a very simple, the coordinate geometry, you kind of the type of distance you have. Okay. Now, because no one asked me this question, I'm going to ask, what can be the distance measured between two classes? I mean, let's say I have a variable, I have a point one. Let's say classes are male, high, low, and I have a female, high, high. What is the distance between point one and point two? Any arbit answers can. I mean, if you don't know this,
Yeah.
you don't know this. There's no. Uh, well, I mean, there's no go around. So any arbit answers can do. But I just want to see how you can figure this out.
So I think we cannot compare between two classes.
That's a good point. You
No,
can,
but we can give some points for high, low. We will change this into point, then we can see the distance, isn't it?
not exactly, Sunil, because if I say high is 1 and low is, let's say, 2 and high is 1, this 2 minus 1 will not make any sense. I mean, a low and high distance is not 1. High minus 1 equal to, sorry, high plus 1 is not equal to low. Someone can say 5 and someone can say 10. Then his distance will be different, right, from what you said. There's no, you cannot actually assign a number to that. Any other answers? So there's something called Jacquard similarity. Name sounds complex, but it's a very easy concept. A intersection B divided by A union B. Simple. How many total possible sets are? Sorry, total possible. Let's say male, female, 1, 2, high, low. These are the total possible values that uh, each of these variables can take. So 4. And what are the common so this is not common, this is common, this is not common, so 1. So this is basically a 25% match, oh sorry, 20.25 or a 25% match between point 1 and point 2. Okay.
Didn't get anything.
Sorry.
Yeah, I understand that formula, Jacquard similarity, but could not map with the column which we have given.
No, this is just out of context. Just since we were talking about distance between 2 points, so we talked about
Yes.
numerical distance. I just wanted to give you a kind of thinking of what could be the distance measure in a class. This is not actually applicable, but in K-means clustering, you can have classes when you do a cluster. Okay, so at that point of time, it may be needed. But anyways, that's not very important. Let's get back to where we were. So if these are very similar, they are grouped into one. Let's say these are very similar, they are grouped into one. These are very similar and they are grouped into one. And let's say these three are similar and they're grouped into one. Now this will be a point here. This did not get grouped. It's a point here. This is a point here. This is a point here. This is a point here. And this one did not, let's say, did not get grouped. Now again, you start your problem like this. You may see these are two very similar. These are grouped here. This did not get grouped. Did not get grouped with anyone, and these got grouped here. Okay, so based on the distances, it is getting grouped, and you're trying. So what will be the final root? There will be a single one. So depending on the clusters, you can. So this is kind of a tree, the same thing. So initial below this there will be, let's say, 2 or 3 which got clubbed into one. Like this, it flows from the bottom. So the top one will be 1 and the bottom will be the number of data points, and it gets clubbed based on the distances. So what is the advantage of it? The advantage is merely no one does hierarchical clustering. If someone talks about clustering, it's generally k-means only. So don't bang your head too much on hierarchical clustering. Just it's good to know. I mean, if you ever give an interview on machine learning, you might impress your interviewer if you say that it's one of the hierarchical system. Anyway. Okay, so is clustering clear then? Can we move on to our next topic?
Yeah.
Okay, let's take a 5 minutes break. Let's get back to it. And after the next topic, which is an linear discriminant analysis, we'll see the codes. Okay, so don't worry, we also have the coding part today also. So it's not only theory today. Okay, so let's take a 5 minutes break.
One request. Can you send this sheet on which you are drawing on your iPad?
Yeah. So this is a OneNote file. So if everyone has an access to OneNote file, I can send that, or otherwise I can convert to PDF and send. Or the only
just convert to PDF. Yeah, PDF and then send us.
The only problem with PDF is that so OneNote has this weird thing. It has an infinite space of page, right? So if I go on scrolling from right, it can go infinite, and down it can go infinite. So when you convert to a PDF, it kind of looks very small. Okay, so
Okay.
Okay.
So send us both. We'll try.
Okay. Sure. Okay.
Yeah. Okay. Thank you.
Okay. Let's get back, catch up after 5 minutes. Hello. Hello. Hey. Okay.
Hey, Shubhdeep. Hey, Shubhdeep, this unsupervised learning is like most likely it's a classification problem, right?
Mm, yeah. It's a
Because we are classifying.
yeah. Yeah. You could say that. Okay. So, any other questions so that, or we can start with the next topic? Okay, then. Okay. Now the next model that we are looking is linear discriminant analysis. Okay. This is a classification problem. Not sorry problem. Sorry, model. Okay. Why? Because we are dealing with probabilities. Okay. Now let's see. We talked about the Bayes theorem, right? Where when we said probability of y equal to any class given x equal to the features equal to probability of x equal to the features y equal to k into probability of y equal to k divided by sigma of k equal to 1 to uh, capital K, whichever are the number of classes. So probability of x equal to x divided by equal to k into probability of y. This is the simple Bayes theorem formula. Okay. Um, Probability of y belonging to a particular class given the features is equal to the probability of x equal to the features in that particular class into the probability of y equal to that class overall in the data divided by sum of k equal to 1 to k, the product of these two. Okay. This we have seen in which model? Very, very minutely, which model we saw. Can you guys tell? Last class, which model we saw? Bayes theorem. Excellent. Naive Bayes. Excellent, Sunil. Naive Bayes. So we saw this very clearly in that. In naive Bayes, what was the assumption? What was the clear assumption in naive Bayes? Can anyone tell me what was the assumption in naive Bayes? Okay, so I'll tell the answer. Naive Bayes, the basic assumption was all the features are independent, right? When we multiplied those probabilities, if you remember, when we multiplied those probabilities, we assumed that the probabilities were independent and there was no dependence on it, which could be a wrong assumption, but that is how your naive Bayes comes. Now, linear discriminant analysis doesn't take into consideration that assumption. Linear discriminant analysis says that it is too hard an assumption. I don't want to assume all my variables are independent, and that cannot be the actual business scenario every time, right? there has to be some dependence on the variables. So linear discriminant analysis, these guys came up with a different approach. They said, I have the same problem, but I'll approach it in a different way. So, okay, very good. So what's your thought? Okay, before we proceed anywhere, we have to understand the PDF function of a normal distribution. I think this I told that I will discuss later, and I think the time has come where we really see the equation properly. So this the normal curve, which is so beautiful to see and easy to draw. Okay, I'm sorry. One thing so very is beautiful to draw and very easy to draw, and everyone follows. This has a very weird and a complex equation. This is the equation actually. So this is the probability, and this is the 1 by root of 2 pi. So this is a constant, uh, sigma square k. So if you take it out of the bracket, this will be sigma k. Sigma k is the standard deviation in that class. So k is that class which we are talking about. Forget k right for now. Just understand the formula. Sigma square into e to the power minus 1 by 2 sigma square into x minus mu square. This whole thing is in the power of e. Don't go too much depth into the equation. It will not help much. But since we are doing LDA, which kind of assumes this equation, so what we are trying to do is we are trying to present this. Rest all we are good. We are good here. So we just say this is a pi k. Pi k is just a symbolic representation, no science behind it. This we are presenting in a form of equation. So basically what we are saying, inside a class given y equal to k, my x will follow a normal distribution. And the probability associated will be an output of this equation. Any questions here? Any questions? Just till here, nothing in the model, just till here. Don't bother yourself too much from the equation. The same knife base equation we are dealing with, just this part, okay, the part that I am bordering with a black color, this part we are representing in a form of equation. I'll stop here. Any questions?
Can you repeat that again, Shubhadeep? That formula,
Perfect.
probability of x equal to x.
You want to understand the formula or just hear me
To
out?
understand the concept.
So there's no concept here as per se in the formula. It's just a formula of this PDF. Okay. So normal distribution PDF will follow this formula. Any point, for example, when you got the mean, you got the standard deviation. So whenever you have a normal distribution, for example, if you have your data like 20, 25, 70, 76, 100, 50. So let's say what is the mean? The mean is, let's say, somewhere around 55. Okay. Then what is the standard deviation? Let's say it's 5. Now I tell you what is the probability of me seeing 27 in this data. Can we find out directly? You cannot find out directly, right? Because there's no 27 in the data. Even if I asked you 25, you still could not tell me the probability as such, right? This is a continuous distribution. So what you do, you go to your equation of normal, 1 upon root 2 pi sigma into e to the power minus half x minus mu by sigma whole square. You put in your mean here, you put in your standard deviation here, you put in x which I want to find, and you give me the probability. Let's say it's 0.2. Okay, simple as that.
Okay.
Sunil, questions? Clear. Okay. So instead of this formula, instead of this expression, I present that in the form of an equation. Now, so this is basically probability of class K given X is equal to the formula which I just told into pi K is the factorial representation divided by, so pi K I have written here only, so no need here. I have written the pi K here. Okay, divided by the sum of that. Simple, right? I've just replaced this part in a form of equation. If you take log on both sides, this will come. No need to go into depth of that what comes. Basically what we are trying to say is your decision boundary between two classes. So let's say this is high, this is low. Your decision boundary will be the center of these two means. So if this is mu1, this is mu2, mu and mu2 by 2, the center of this will be the decision boundary, and that will be a linear decision boundary. I know that it's not clear, so I'll again state. So for example, if you have a data like this, your y equal to high is like this, y equal to low is like this. Now, what is your decision boundary that separates these two? I mean, what is the, let's say, so for example, in support vector machine, we had a line that was separating these two. So similarly, what is the line that is separating these two? So the line will be like this. Mu1, if this is the center of this, mu2 is the center of this. The center of these two centers is the line will cross through this part. Okay. So actually, this is a little complex model to make you understand. So can you ask me specific questions so that I can clear that better instead of me being me being uh, what do you call, guessing that which part you don't understand. Can you just ask me questions on this?
Yeah, the one you drew the line, you found the point based on the center of from the center point, right?
Correct.
The middle, right? Then how is this line represented? What is the data for the line?
Okay, good question. So you understand this this equation. So
Yeah.
this equation came from taking the log of these two equations. Now, like for k, let's say k equal to high here. Similarly, k equal to low will come as an equation here. Now you equate these two equations. So when you equate means that probability of a point falling in high and low is equal. It means that point should be lying on this, right? Here, the probability of this point falling in high is higher. Here, the probability of this point falling in low is higher. On this line, it means the probability of all those points which are kind of having an equal probability to go on either side, those points will be lying on that line.
No, but that points you're telling is the cluster point. That's what, right? Each cluster point, right?
No. See, this is an equation. Okay, so now, for example, this is the x. This is so x will come from the data. This you have calculated the mean. This you have calculated from the data, and this is a prior probability. Okay. Let us understand each of the components of the mix, and I think it will be clear. So x will be coming from the data.
Okay.
Okay. This is k sigma. So what is sigma k? What is sigma k square? Is basically standard deviation of the data in kth class. Okay. Similarly, what is mu k? Mean of the data in the kth class. Okay, so all these things will be calculated. For example, okay, let's take an example here. So your data was like this. Let's say x1, and you just have a y. Let's take only one dimension. It's easy for you to understand. Okay, so now let's say you have 1, 2, 3, 4, 5, and another 6 data points. Okay, now your high is your high, low, low, low. Okay, so x1, let's say 20, 26, 27, low, let's say 40, 45, 70. Okay, now if you can understand this, now let me, okay, I want you guys to calculate what is mu high. Actual numbers I want. You can use a calculator. What is mu high? Okay, I'll assign names to each of the band. This Krishna will answer. This Sharad will answer. Mu low Sunil will answer. And sigma low Vasant will answer. What is mu high? Krishna?
Yeah, 1 second.
Yeah.
Sure. Yes.
Mu is the mean.
It's like
Mu is
23, 23.5 something.
okay. Let's see. This is 53 plus 73. 73 by 3 is around 24 point.
No, high, right? You want only the high.
Yeah, only the high. So this is high, right? So 3B.
Oh, sorry, I missed one more. So yeah, 20, 26, 27.
Yeah. 53 plus 2073 divided by 3, it's around 24.33, right? So this is 24.3. What is sigma high, Sharad? Okay, sigma high will take time. What is mu low? Mu is the mean. Sunil, mean of y equal to low. Okay, just tell me which data points you will consider, Sunil.
I think it's 51.6.
That's Vasant, right? Sigma low, right? Which one you're telling?
Yes, yeah. No, mu low.
Mu low. Okay, mu low, let's see. 85 plus 70. 155 divided by 3 is around 51. Yeah, 51.6. 51.6. Sunil, why didn't you answer? Any doubt, Sunil? Are you finding this to understand?
No, basically, I'm really sorry. I was out for 3 minutes.
Oh, okay, no problem. Okay. Vasant, sigma low. Oh, no need to calculate. Just tell me the formula.
Oh. Square root.
Whatever it is, this is 121 something. This is 36 plus this is how much? 19, right? 19 is 381.
Is it something 3.78 something for the height? Standard deviation.
Yeah, so it could be something like that. So 2412 plus. Yeah, it could be something like that. How much you said?
So sorry, 3.7 something.
3.7. I'm not sure. 4.33 whole square plus this is itself more than that. Then 26. This is something like 1.7. See, I'm making you do hands-on so that it's clear for everyone. I think it should be more than 3.7. How did you calculate?
Four point three.
Your mu high was 24.33, right?
Yeah, that's correct.
Okay, so what is the difference between 20 and 24.33? That's how we calculate the standard deviation. 20 minus 24.33 whole square plus 26 minus 24.33 whole square plus 27 minus 24.33 whole square. And then take a root, right? Hello?
Yeah, you're correct. Yeah, that's how we did. Maybe I missed somewhere. Give me a second. Let me.
Yeah, no problem. See, if one value is greater than 4, it means the whole thing will be greater than 4 because we are adding positives, right? So that's why I told you that 3.7 could not be the answer. Anyways, you guys get the essence, right? Sunil, since you were not there, did you understand this flow?
Basically, yeah, no, basically, I understand that PDF distribution, which we took from the probability and used in that equation. That's clear.
That's clear, no? Okay. Now, what we are doing here
Yeah.
is we are trying to calculate the sigma k and mu k for each of the classes. So since it's difficult to, you know, show you in the picture, I was taking a sample data set. So I was just asking them to
Okay.
calculate what is the mean, what is the sigma in high, and then what is the mean and in sigma, what in low.
Okay.
Okay, so for example, mu high is 24.33, sigma high is something, let's say, I think it should be, let's see, 9, 16, 25, something around 5.5,
Yeah, so it will
something.
be okay.
Mu of low is 51.6, as I think Vasan said correctly, and then the standard deviation is, I don't know how much it is. So anyways, whatever it may be. So 380,
Okay, that's fine.
something around 20.
Basically, mean and the standard deviation we are calculating here.
Yeah. Now,
Mu is mean.
can you guys
Am I right?
actually calculate each of the values? Because I want you to find the value. Tell me the probability of x equal to 25 given y equal to high. Can you guys do this for me right now?
I think so last time we did the same, but here
No, it's not the same, Sunil.
they
That's why I'm saying here we are putting in equation. We are not calculating this from the data. We are doing from the calculation.
because last time also we did the same. X equal to something, y equal to something. As there is no 25 for x, so it will be 0, isn't it?
No, Sunil, not like that.
Okay.
Knife base, you remember?
Yeah, we should.
Yeah. So we did a class
Yeah, fine.
when there were classes like these, when these were classes, yes, no, then Sunil is right, right? When we just see that and calculate. But when these were continuous variables, do you remember we kind of fed in the same thing in the probabilities in the PDF of the normal?
Yeah.
Okay, guys, you need to revise the previous slides because If you don't revise, it is difficult for you to catch up. See, when you have a continuous variable, you cannot do what you were just saying. Since 25 is not there, I cannot say it is 0 because it's a continuous variable. When we have yes or no, for example, when we were doing right, Sunny equal to yes and Sunny equal to no, and then what was the play? Then we were saying what were the number of occurrences of yes divided by the total number of occurrences, and we could say. But in case of continuous variables, even in the naive base, I told you that we have to feed in this equation. But that time we didn't too much stress on this equation. That's why I'm saying kindly do this. Otherwise, it will always remain a confusion. Do this. I have this data set. We'll exceed some 10 minutes today, but let's be clear on this. Let's not be in a shadow of doubt. Okay, let's do this. If you have x1, your y is let's say here high. Okay, let's keep this simple so that your means and all everything can come up easily. 40, 45, 50, high, high, low, low, low. I'm making your life simple. I'm saying mu high equal to 25, sigma high equal to 5, okay, and mu low equal to 45, sigma low equal to 5, okay. Now tell me what is the probability of x equal to 27 given y equal to high. Come on, do this. I want the answer, real answer. The equation that you have to use is this one. I'll write it here properly so that you can take a reference of it. 1 by root of 2 pi. Okay, let me write it properly. Wait. 1 divided by root of 2 pi sigma k e to the power minus half x minus mu sigma k whole square. Use this equation, use a calculator, and tell me what is the probability of x equal to 27 given y equal to high. So basically k equal to high.
So Subhadeep, everything you have given, just you have to put the value and we'll get the value, isn't
Whatever it may be, you tell me the answer. I'm not. I will make sure that everyone finds out the answer.
So it's mu is 25.
Correct.
And sigma is 7.07.
Okay, you calculated. Okay, that's great. But I just mentioned it. Just assume it to be 5. But that's okay. If you have calculated, that's okay. You tell me what is the probability of x equal to 27 given y equal to high. At least tell me what you have fed in the equation. What all values.
Right. So here we have got this sigma. So 1 upon 2 pi sigma is 7.07.
Perfect.
And then x is our 27.
This is not x.
27.
I mean, that is into e to the power.
Oh, into, okay.
Yeah.
So into e to the power minus half, and then x is 27.
Perfect.
Minus mu mu is 25, so that means 2
Correct.
divided by 7 and then whole square.
Correct. Perfect.
So whatever is that number.
Whatever
So
that.
if you standard deviation as 5, it's around 70%.
Perfect. Okay, that may be that's a good. I think that will be the answer. I think so. Now you get it right. So when your value is not there, but if you have a continuous variable, you can still find out the probability of that number given a particular class and calculate its probability. Now, if you give, if I tell you what is the probability equal to x, probability for x equal to 50, given y equal to high, that will be very less. You can just check. Can you just do that also? X equal to 50 when y equal to high.
Yeah, it will be by looking at this number. It will be because after 30, it's low always. Y is low, right?
Perfect.
It
Yeah,
will be.
that's the essence. But can you give me a number so that we have some reference to uh, talk about?
Yeah. So mu and sigma we have got. So 50 minus 25 sigma, which is 7. Right.
Sunil, are you getting it?
Yeah, I've got this. Just I'm using calculator.
Okay, perfect, perfect.
So formula is e to the power minus 1 by 2, right?
Correct, correct, correct.
So it is coming e to the power minus 6.3. I don't have this scientific calculator. So
Okay, that's okay. Can Krishna? I think he was having a calculator. Can you tell me the value?
Give me a second. Is it around 0.6 percentage or something like that? 6 percentage or 0.6?
6%. Anyways, it will be very low, or whatever it may be. I'll probably check in my calculator, but it will be very low. So the essence why I was asking you to do this is basically now you have ingrained in your mind that it's not that when we have continuous variable we cannot find out the probability. The only first thing you have to do is assume a distribution. So assume this distribution, assume this as an equation of normal distribution, and then proceed with the calculation of your what do you call the probability. Okay, now since now you have done this, it's okay. Now let's feed in the proper equation. Okay, now let's say my problem is I get a data point, let's say 70. Okay, now what is my probability of y equal to high, and what is my probability of y equal to low, or let's say whatever we have calculated for 50. Okay, now probability of y equal to 50. So probability of y equal to high when x is equal to 50 is equal to probability of x equal to 50 given y equal to high into probability of y equal to high divided by the summation. Forget that. What is this? We have just calculated. Let's say Krishna is right, so we have 0.066%. Okay, and what is probability of y equal to high in this case? There's an external noise. Can you put yourself in mute? I mean, there was okay. Now it's gone. Anyways, so what is probability y equal to high? From this same data, hello,
Yeah.
yeah,
The probability is like 50%, right?
excellent. Yeah, it's 50%. So 0.5. Because high is 3, low is 3, so 3 by 6. Okay, so 0.5 is the probability, and then you have the denominator. Now when your probability of y equal to high is probability of y equal to low, okay, so these are called prior probabilities. Okay, so we saw this in equation, right? So we got this equation after taking the log of the same thing, and we saw that when the prior probabilities are equal, okay, here our prior probabilities are equal, right? Probability of y equal to high is 0.5, probability y equal to low is 0.5. Then your decision boundary is basically the average of this plus the average of this by 2. So what was the average of this? 25. And what is the average of this? 45. 45 plus 25 divided by 2, this is 35. So whatever falls greater than 35 is low, whatever falls less than 35 is high. Do you get this? So what was the decision boundary, like we were speaking, right? You that time you were asking what is this line. So this line is equal to x equal to 35 right now, right? Because your pi k is equal to 0.5 for both cases, right? Probability y equal to high equal to probability of y equal to low, right? So this was equal to 0.5. Now this got cancelled out and this condition came up. So what was the, so what is x? X is equal to 25 plus 45 divided by 2. So x equal to 35 is your decision boundary. So whatever falls below 35 is high, whatever falls above 35 is low. Is this clear to everyone? Each and everyone. I want, if any doubt is there, then I will not go ahead. If it is clear for everyone.
Question is, sorry, it is just one value, right? For a point, we have two values, right? That's where I'm a little confused. You have 35, right?
Correct.
Right, but when I'm going to plot, what does 35 mean?
Okay,
Like,
so right now you have just a one dimension, right? So your decision boundary is basically this. So x equal to 35, whatever falls beyond this is low, and whatever falls beyond this is high. For example, if you have two dimensions, then your dimension will be like this. So whatever falls beyond this high, and let's say
okay, got it.
something like that. Yeah, this is low. Right now you have only one dimension.
Okay.
So Neil, is this clear? Sunil? No, not almost. I want specific questions why it is not clear or why it is clear. I want specific questions because I don't want. No, ask me question. No, ask me the direct question or ask me anything you want, but get it
Okay.
clear.
No. Sorry for that. So I got all the probability high and low, and now I need to that 35. How did you calculate that thing? I couldn't understand.
Okay, fair enough. Just park that question. Any other questions apart from this? How did 35 come up?
No, after that I understand. Yeah, why it will be low? What is the decision boundary? I understand.
Excellent.
Only 35,
35.
from where you get that.
Oh, okay, perfect. Any other? I mean, apart from you, Sharad, Vasant, any other question apart from Sunil's?
No, because a lot of math calculations are going on, so it's
Yeah,
tough
I
to
understand. That's why
concentrate on
I'm
this.
going very slow on this. That's why I'm going very slow on this. That's why. Yeah, Sharad, you were saying something.
No, I said okay. Yeah, for me, no other question.
No other question. Vasant?
Yeah.
Okay.
It's
Okay, so just we need to address how x equal to 35 came up. Okay. So Sunil, this part you understood, right? This part
Yeah.
you are comfortable? Are you sure?
Yes.
Okay.
Yeah, because from there we derive the final equation,
Yeah,
which is
perfect.
very simple.
Exactly. Taking log on both sides and you just find out the. So here, what are the components you see here on this equation? If I just zoom here, what are the components you see here?
Okay. We need x,
X,
then derivation mu.
correct.
Yeah, and
And
yeah,
then
that's all. Only these two things we need.
standard deviation
And x.
between X and
Yeah,
what about
standard
pi?
deviation mu x.
What about pi k? This all you don't know,
Okay.
right? Pi, what is pi k?
No, that thing I don't know. Pi.
See, if you have understood this, that's why I'm asking repeatedly. If you understood this,
No. I mean, in the last equation from where we calculated um, 35 when y is high, that log pi k was not there.
okay, no, that's what I'm asking. First, you tell me, did you understand this top equation? This one. Are you clear on these components, each of the components? Or you're not clear about pi k here?
Only pi k that is not clear.
That is not
Standard
clear.
deviations
Okay.
all are.
So it means this one I told, right? Probability of y equal to k is pi k.
Oh, okay.
Okay. Now, are you clear about probability y equal to k? What is probability of y equal to k?
Yeah, this thing I have assumed as a pi k.
You have assumed, but what is that? You're clear now.
Yeah, this part I am clear.
Okay, perfect. So if you know pi k here, that means you have understood this equation, right?
Now I understand everything because pi k that term was not clear, but that equation was clear to me.
Okay.
So that equation you have put here pi k. After that you are taking the log, and finally you are calculating what is that sign you are given.
Amazing. Yeah.
Yeah,
Now,
x.
what I say is a x point wherein my probability equal to y equal to high and probability y equal to low is equal. That means that is my decision boundary. That boundary beyond,
Yeah,
right?
that's correct.
A decision boundary which separates. Where did that go? Where is that diagram? Yeah. So here my probability of high equal to y equal to high is greater. My probability y equal to low is greater. But at this point, or at this point, or at this point, both are equal, right?
Yes.
Okay. So it means if this is the probability and I equate this, okay, now let me take this equation and solve it for you. Can you see? Let's keep it high and low here. This is the probability of y equal to high given x. Agree? Same thing. I'll just replace k with high.
Yes.
Okay.
Yes.
Which is should be equal to agree. This probability should be equal to, so this is probability of y equal to high given x. This is probability of y equal to low given x. When will be this equal? This will be equal on the decision boundary, as we said here.
Yes.
So it means the x that we get from here should be equal to the should be lying on the decision boundary. Simple maths.
Yeah.
Equating two equations, finding whichever x satisfies this equation, it should be the decision boundary, right?
Yeah. This is clear.
Clear. Okay. I've said that pi high and pi low are equal. It means it cancels off. Pi high and pi low is equal. Pi high is
Yes.
0.5. Correct? That means it cancels off. If you solve this equation, it will come x is equal to mu high plus mu low divided by 2. Is this clear? So there is an assumption, inherent assumption behind that, how this comes to here. But solving this equation, this will come. Or should I show the steps here?
No, it's okay. We'll do that.
Okay. So the assumption is sigma high equal to sigma low. That is one assumption that you are taking here. Okay. So this is called the shared covariance. Okay. No need to go into that, what is shared covariance, but just assume the inherent assumption of LDA is that the variance across the two classes is similar. And that is not a very weird assumption to keep in. So for example, here it was something, one was 5, one was 7. So you assume that if it is a normal distribution and if it is two classes, the distribution, or sorry, the standard deviation would be kind of similar. That is an inherent assumption that your linear discriminant analysis takes into consideration. Okay. So mu high, what was it? 45. Mu low was 25. Sorry, it was the reverse. 25 plus 45 divided by 2. 45.
Yeah.
Okay.
Yes.
I'm not very confident that you've understood. I don't hear a very confident.
No, I understand. Definitely, I'll, because these are math calculations. We have to go take notepad and we have to go one by one.
Okay.
But it's clear everything.
It's clear now. Okay. So this finishes our modeling part. Okay. So we have completed LDA. Okay. So since we are almost running out of time, so I will show you tomorrow what we'll do. We'll show the codes for clustering and LDA, and then we have a project work tomorrow.
So this LDA we are calculating to decide the boundary for this clustering.
See, don't mix up two definitions. Clustering is different. I've explained you clustering is different. Clustering is unsupervised learning, right? Clustering has nothing to do with LDA. This is what I showed is okay, maybe there's a confusion here because I've never mentioned decision boundary earlier, but right now I've mentioned a decision boundary here. Okay, so if you remember SVM support vector machines, we were drawing a line maximum marginal classifier. If you remember, you were separating two classes.
Yes.
Okay, so that was a decision boundary. Similarly, in LDA also we have a decision boundary. So what is the particular value of x beyond which you would say that the class is hard changing? So right now we just have a one dimension. When you have multiple dimensions, then the curves will be, I mean, the picture will look different. Right now we just have a one dimension. So what is the objective here? What your objective is basically to calculate what is the probability of high given a new point, right? So this already you are getting, right? This probability you are just getting. But I just wanted to explain you how a decision boundary is built. Since LD is a good example to show you, and SVM was a good example to show you, that's why I showed. Otherwise, your objective is always what is the probability of y equal to high given a new x point, right?
Correct.
That you have already
So
calculated.
tomorrow we are correct. So tomorrow we are doing project work. Wasn't it decided for the last week?
Now, last week we have natural language processing and deep learning.
Okay.
Because those we will not see the codes in detail. Those are more of theoretical, and we'll see just wet our feet on those concepts. We'll not go into too much depth. That will be a separate course for deep learning. So deep learning will be a separate course that we will launch, and in that case we will go in depth in deep learning. And deep learning is really very deep learning, and NLP is very interesting. And if you want to continue learning more about modeling and how deep learning can you know um, uh, defeat all these models that we have learned, then we can you can also go in for that course according to whatever your needs are. But deep learning is NLP will be a different.
Yes, two questions basically. One question regarding that project work. What are we going to do? Means you will give us a problem and we will come up with a solution, or you will take a problem and you will go one by one step to finish that.
Yeah, I'll take a problem and go one by one step to finish it.
And regarding that deep learning, yeah, that's very means that is trending and that is required.
Yeah.
So, what are you going to let us know in deep learning? Means because as you told, you are not going to cover the modeling and as I know, modeling that is one of the important tasks. Without this, there is no use of deep learning.
Correct.
So only describing means neurons and how neurons are interacted, and that is the step for the deep learning, basically how human thinks. So these are the theoretical part. It will be finished in 30 minutes only.
No.
So modeling, could you give us the basics of modeling?
It will not.
Simple example.
No, it will not finish in 30 minutes. Deep learning theory is huge. There is matrix multiplication. There are a lot of things. So we'll see how much. But see, modeling will not be able to finish in 1.5 hours or 2 hours. Deep learning is of different course. Okay, so we'll wet our feet in that concept. So we'll understand how deep learning is improving these models. What is it actually doing? But we'll not go inside the code because neither it is possible to explain the code in 2.5 hours, or neither is it possible to even set up.
Yeah.
Deep learning will have a different setup also. You need to have a TensorFlow, so that even setup is not can be done in 2.5 hours. So, but we'll see how deep learning, improve.
Yeah, so at least basically, Subhari, basically in 2.5 hours, whatever time you will give, I should be confident enough to understand the deep learning.
Yeah.
And how to model this basically. I'm not going in the modeling algorithms or anything.
Uh-huh.
So because machine learning, that was easy for us because we were familiar with the data, supervised learning and unsupervised learning, this type of things. But deep learning, that is very new, only basics. I don't think so. I'm not sure whether others know or not. But in case of me, just I know the basics. Neurons, these are the way it has been modeled, but deep learning, that is very important to understand us so that we can decide whether we have to go in deep learning or not.
Yeah. So that's why I am going to give you that uh, picture of how deep learning. Let's say if you want to pursue deep learning, then how it will proceed, and how what are the complexities in it, and how it improves the present models, how it functions differently, what is its setup, how it is different from the current setups of machine learning, how it can be used for supervised learning, how it can be used for unsupervised learning. That basic introductions and basic this will I'll give you. But deep
Yeah, I think so that will be great. Yeah.
deep
No,
learning,
definitely, in 2.5 hours it can't be covered. I know this.
yeah,
It will be a
it can be
separate session.
model. But since this was the objective of this course was to understand machine learning very thoroughly, right? So that is what we need to focus. That your machine learning is very clear, because if it is, see, that's what I'm saying. These equations and all, these are, in deep learning, you start your deep learning with equations. You start with your deep learning with stochastic gradient, and gradient descent, all back propagation, differentiation. A lot of maths is there. So that's why your deep learning course itself, to just get to know the maths itself, would take around 2 or 3 classes, or even more than that, just to understand the maths, because there's a lot of maths involved in deep learning. So that's why.
Sorry. Is the class over? I have to step out.
Yeah,
Is
yeah,
that
sure,
okay?
sure, no problem. The class is over actually. So tomorrow
Okay,
we
thank you.
will see the codes for clustering and project. We'll start.
Okay, sure. That would be great.
Yeah.
Thank you much.
Thank you so much. Yeah, thank you so much.
And Shubhadeep, one more request.
Yeah.
Instead of one day next week and one day next to next week, why not we are taking both classes next to next week only? So that at least one weekend will be free for us.
Okay.
Sharad, and
Yeah, fine with
we can
me.
ask Sharad question.
Yeah, we can have the next week off, and then probably we can resume week after.
That also I can, I because I just need to talk to Ashok regarding the options. Because he has to take the final call, and I'll just convey that all the participants are okay with that, and if he gives a nod, so I don't have any problem in that.
Okay, that's great.
Yeah, but but Sunil, that's what I'm saying. If you want to pursue deep learning, that's great, and if you want to go in depth, so we will have a course for deep learning separately. But it's good to know deep learning, but it's not that every problem is solved with deep learning. Don't get too much excited what the external world sees, huh? Because I am doing
Okay.
this business in a lot of things. So it's not that every problem will be solved by deep learning, and machine learning is just waste. Whatever we have done, it's not that. Deep learning can solve particular problems which cannot machine learning cannot solve. But there are particular problems
So,
machine learning can solve, deep learning cannot solve, right? So it's not that deep learning, once you learn deep learning, all the machine learning goes waste. It's not like that. And deep learning,
yeah.
there are certain problem states. For example, the project pattern recognition I did deep learning and gradient boosting, but gradient boosting performed better than deep learning in my case, right? So it's not that machine learning is a waste, and deep learning is all what we need right now.
Okay, because with one of my friend I was discussing, he told if you want to go in machine learning side or new field you are choosing, why not directly going in deep
No,
learning?
no,
Why are you
no, it's not correct.
studying with machine learning?
Not correct. It's
Okay.
absolutely not correct. If you don't know machine learning, you'll never understand deep learning. First case.
Oh, okay, that's great. Okay.
Second case, it's not that deep learning is a solution to all of your problems, right? In case of deep learning, there are a lot of machine learning concepts or machine learning models that will come into picture in deep learning. That's what I'm saying. Deep learning is not something that you have. So when your data sets become very complex, right? It's not about just a single model. It has to have multiple models. I built a model I built a solution which has 10 models in it, right? So 10, or someone can build a model with a solution which has 100 models in it with different hyperparameters. So it's not that deep learning is the straight thing. And see, if you don't know machine learning, you will never understand deep learning. That is for sure. That I can guarantee. But if you understand machine
Okay.
learning, it's much easier to understand deep learning. And if you
Yeah.
want to do deep learning, then it's not that machine learning is a waste. That's how I would put it.
Okay.
And
Okay, that's great. I think so. After 2.5 hours, I'll decide whether I have to go in deep learning or not.
but
Whether that interesting for me or not. Yeah.
So deep learning, I will tell you, if we have 2 minutes, I just tell you deep learning, it's very maths intensive. It's difficult to implement, okay, Results are very good. Obviously, results are very good in certain cases, especially for unstructured data. If it is for structured data, then machine learning models are much better. But if it's unstructured, like text, image, okay, let's say videos, for these deep learning, but real business problems, like for example, Johnson's database, right? It is more of structured data. For that's where I need machine learning. Deep learning will not help, and deep learning will need a lot of data points. Minimum, let's say, 1 lakh data points deep learning would need. If it's too less, let's say 100 or 200 data points, deep learning will never help. Okay, so
Okay.
don't get disheartened that will not learn deep learning and machine learning is just waste since deep learning is there. It's not like that. Deep learning will perform terribly bad if you have too less data and your data is too structured. Then your boosting will perform much better than deep learning. So out of
Okay.
6
Yeah.
projects that I'm doing, I'm just implementing deep learning in one of them. That because it is of unstructured data. Other 5 I am doing machine learning.
So, sure, it means in every class we have been talking about the theory, math part, and then programming part.
Yeah.
So, my question is, there are two terms frequently used. One uh, that is related with stats, and another one is related with programming.
Correct.
So, means stats mathematician that is required very much there, who can understand the data points, everything,
Correct.
and another part that comes programming. So, as a programmer, as for example, I am a programmer.
Correct.
So, do I need to understand those data very well or not?
Yeah, of course you need to. So, if I can say, a data science, if you want to go be a good data science, okay. So,
Yeah.
if you consider data science as a Venn diagram, so one set will be data, or let's say business. The other set will be programming, and the other set will be statistics. So the course I did, right, the masters I did in
Okay.
data science is taken up by 3 in different institutes. See how data science is important in these 3 different domains. So my technology part was handled by Indian Institute of Technology, Kharagpur, which is the best in engineering and computer science in India. My management part, the business part, is being handled by Indian Institute of Management, Calcutta, and then my statistics part is handled by Indian Statistical Institute. So each of the 3 institutes taught us their different expertise. So I did. It's not that Indian Institute of Management sole provided me this masters. It's not. Individual institutes taught me. And that's why your understanding each every part is equally important. You cannot neglect any of them.
Okay. Okay.
Okay. Okay, then let's close for today. Let's meet tomorrow. Okay. Okay.
Okay. Sure. Thanks a lot.
Okay. Thank you so much.